Fusion Mobile, quality e-learning experience on the go.
And I'll be walking you through the physics course. Today we'll be talking about crystals. And in this topic we'll be considering crystal characteristics, arrangement of atoms in the crystal structure, non-crystalline or amorphous substances, and also we'll be comparing crystalline substances with the amorphous substances. So, what do we mean by the word crystal? A crystal is a solid that has a definite melting point. That is one of the major unique features that identifies a crystal from other substances. It has a definite melting point, and apart from the fact that it has a definite melting point, it also comes with a structure of its own, which is unique to itself. That is, it has a unique structure for each type of it. For every crystal, a compound that exists in the crystal form has that same structure for every atom, every compound as such. That is, if you have a crystal, say a diamond, it maintains that same structure. If you look at one diamond and you look at another diamond, you see the same structure in both of them. And there are on some certain occasions, you have certain structures common to one or two other crystals. Crystals that you share the same type of structures are said to be isomorphous. In a few seconds, so a question will pop up on your screen to check your understanding of what has been discussed so far on crystal characteristics. Welcome back. Let's talk about arrangement of atoms in the crystal structure. So, the atoms in the crystals, like I said earlier, the crystal actually has a definite shape. Its definite shape means each atom will stay in a specific position. You do not expect to find atoms moving around, changing positions. No, they maintain their specific positions. And this is one of the reasons why it possesses a high melting point. Crystals are very common. They are known to have very high melting points. And the arrangement of these crystals in the structure is described as the crystalline lattice. This describes how the elements, the atoms, are being arranged in the structure. These crystals are bound together by electrostatic force. And this electrostatic force is what keeps it together as one component, as a compound of its own. Non-crystalline or amorphous substances. When we say they are non-crystalline, it means they do not come in form of crystals. Many of these non-crystalline substances, amorphous substances, they do have irregular shapes. They can take any form. Generally, they are soft in nature. They can change form with ease. And a particular compound might actually appear, it may be the same thing, but when you look at it at another particular point in time, you see the atoms arranged in a different order, even though it is still the same chemical compound. The word amorphous actually suggests something being without a definite shape, being irregular. So what are the differences between crystalline and amorphous substances? Take a good look at your screen right now. Yes, right now you'll be seeing pictures of crystals and amorphous substances. You'll see a cubic crystal, you see a prismatic crystal, an octahedral crystal. Amorphous substances are actually shapeless, so you see something that is looking wavy, thing like that. Now, what are the differences? How do we differentiate? How do we know them for each other? While crystalline substances have definite shapes and the atoms are arranged in a particular regular pattern, amorphous substances do not have a definite shape. That's the first thing that differentiates them from each other. Crystalline substances have definite melting points. And crystalline substances are usually soluble. Amorphous substances are not usually soluble. For amorphous solids, crystallization of the melted material never takes place. That is, it will never form a kind of crystals. But when a crystalline material is melted down, it will recrystallize. Amorphous substances soften when heated, but crystalline substances rarely do. Crystalline substances are either hydrated or anhydrous, but all amorphous substances are anhydrous. Yes, bear it in mind, I said hydrated and anhydrous. Hydrated means it contains water. That is, whenever the reaction ends, for the reaction to occur or be finalized, water must be involved. While anhydrous means it contains little or no water. So, very good examples to use to describe the difference between crystalline substances and amorphous substances is the situation of carbon. Carbon can be found, you can find carbon in form of diamond, and you can also find carbon in form of soot called charcoal. The diamond structure of carbon is a crystalline structure of carbon, while we have the soot or the graphite or the charcoal as the amorphous structure of carbon. Your charcoal can exist in almost any shape, anyhow. Even when you break it down to the simplest form, you see that it does not have a regular shape. It does not have a consistent shape. It does not have a consistent arrangement in its structure. But in your diamond, it always goes with the octahedral structure. In this topic, we talked about crystals, and we considered the characteristics of crystals. We said crystals have definite melting points. They have definite shapes. They have definite appearance. And they have definite positions in which their atoms stay in their structure. We talked about the arrangement of the atoms, of course, and we also mentioned the non-crystalline and or amorphous substances. We say they do not have a definite shape. They may have multiple melting points, and they may actually they do not have any shape at all. Their structures can be arranged, their atoms can be arranged anyhow within their structure. We talked about the arrangement of atoms in the layers, in the structure of crystals as crystalline lattice. And we also compared the crystalline structure, the crystalline substance and the amorphous substance together with each other. We said crystalline substances are generally hard. They have very high melting points. They have definite structure against what we have in the amorphous substances. The crystalline substances are either hydrated or anhydrous, but the amorphous substances are always anhydrous. And of course, we gave a perfect example to show the difference between a crystalline substance and an amorphous substance. And the crystalline substance we chose was diamond, and the amorphous substance we talked about was charcoal. Yes, both of them are carbon, but their structure differ. And that's one of the major reasons why one of them is harder than the other. Having spoken about this, in a few seconds, some questions will pop up on your screen. Please attempt them. And if there is something you do not understand, you can view the video one more time.